Good afternoon. Okay, Rohit, how's the audio now? There's a problem with YouTube. You cannot you cannot talk. I can't share the screen also. You have to just give me a feedback on the audio. Is it better than Zoom? Or I'll forward the link in WhatsApp. What forward you will link? WhatsApp. Already have shared it in Telegram. No, everything is fine. Okay, fine. So, guys, we cannot waste much time. So you just have to. So whenever I ask you to just, so if you are having a soft copy of the book, I would expect you to go to page number 61. In case if you're having the hard copy of the book, you have to go to page number 55. So 55 in the book, 61 in the soft copy. So if you look at page number 55 of the book, I'm talking about the hard copy, you can see that I would say that the groups 50, 55. All right. Please delete from the groups. Okay, leave it that. That's okay. That is okay. That's okay. We can't do anything about it. You want me to delete it? I will delete it. Okay, delete. Okay, I have deleted it. Okay, so guys, sorry, I'm getting, it is getting late for me. All right, so this is what I wanted to say, that the mean median mode alone, we cannot come to a conclusion. We cannot come to a conclusion that who's, I think there are only three participants. Ask others to join. The mean median mode alone, we cannot come to a conclusion. We need to have some other criteria so that we can decide who is the hard copy page number 55, so that we can come to a conclusion that who is the best and who is not the best. So that is the reason why we have something called measure of dispersion. So you can see that the first person, he is consistent. The second and third person, especially the third person, he is not consistent. So we use certain terms like standard deviation, we use certain terms like variation. Okay, all those things we will be using. Okay, and this is what we are going to learn in measure of dispersion. So measure of dispersion is all about, we will be actually talking that how is that the data that is we are having is deviating from the mean. Okay, in the measure of central tendency, we discussed about how it is all about commonality in terms of mean. But when it comes to the measure of dispersion, we are actually talking about how well it is deviating from the mean. I'm talking about the deviation part. Now, when it comes to the measure of dispersion, we will be talking about three different things. One is that range, mean deviation, and standard deviation. Okay, let's quickly start with the range. If you are in page number 56, so you just have to quickly go to the page number. All right. Okay, now you just go to this page number 50. That's the next page. You can see that range. So what is meant by range? Range is nothing but it is the difference between the large number and the small number. You look at, there is one simple example that they have given. That uh, they have given some set of individual series. Find the range and coefficient of the range in the following items. They can see that some items that they have given, and they have given some series of range like 110, 117, 129. If they're asking you to find out the range, it is very simple. It is the difference between the highest value and the lowest value. The highest value is 790 and the lowest value is 100. Okay, 1 minute, guys. Okay, so this is the what we call it as range. Okay, they might also ask you to find out the coefficient of range. Coefficient of range is nothing but it is a ratio of difference between the large and small value divided by the sum of large and small value. The formula also that they have given, L minus S divided by L plus S. L is the largest value. Largest value in this case it is 790. Okay, and the smallest value is 100. So difference between 790 and 100 on the numerator side, and on the denominator side 790 plus 100, you have to add it, right? So now this is what it is, guys. So now coming to the second one, say for example if they are given in terms of continuous series, okay, individual series or discrete series both has the same meaning. The another one is a grouped series or continuous series. If they are given like this, there is a small printing mistake in your book. You can see 10 to 20, 20 to 30 like this, and 50 to 100. Okay, instead of 100 by mistake they have given it as 10, so you please add one more zero near to that 10, which is nothing but 100. So now in this range the highest value is 100 and the lowest value is 10. So what is the range here? 100 minus 10 is 90. Coefficient of range is nothing but the difference between 100 and 10 divided by 100 plus 10 that they have given in the next slide. So I'm sure that this should not be a problem. Okay, guys, I'm actually skipping the mean deviation, which I feel it is not important for you. So I'm going to the another one called standard deviation. So I'm skipping page number 57, 58, 59, and I'm straight away going to 60. So I would advise you, you can read on your own if you have time. I don't think so it is that much important, because I have not seen any questions related to this mean deviation. Because I mean, if you are interested, you can have a look at it. It is not very tough. Okay, I am going to another one called standard deviation and variation. Okay, this is one common questions which they ask. Okay, so in this chapter, range, variance, standard deviation, these are the main questions they will be asking. Okay, so that's what we are going to cover it. When it comes to the mean deviation, you can read it on your own. I don't think so it is that much important, but if you have time, if you want to attempt, you can read it on your own. We can't cover each and every page in the book in this fast track mode. All right, so guys, I would advise you to just go to page number 60, which talks about the variance and standard deviation. So now what is meant by this variance? So the standard deviation is what, to what extent that my value is deviating from the mean. Okay, that is what we call it as standard deviation. Just remember the word standard deviation. Deviation means what? From where you are deviating from the mean. Let's say that, for example, uh, how do I have to explain? Let us say that there are some 13 students in AU class, okay, and 13 students, I start collecting the of height of all the students. Let's say we have Rohit Mins is there, Risha is there, Ashika, then Balendu, then all the students. I'm collecting all your heights, okay, and I say that Rohit Mins is having a very high standard deviation. Rohit means is deviating very much from the mean. The mean is the weight of an average person, okay, which I can consider it as somebody, let's say, okay, I mean, Shubham Patidar to be an average weight person. Okay, so whoever is weighing higher than Shubham Patidar, I consider to be as deviating from the mean, and whoever is weighing lesser than Shubham Patidar, I can consider him or her as also deviating from the mean. So this is the rough understanding of standard deviation. Now there is a formula for it which I have to consider it for my solving the problem. And the formula is, and what is meant by variance? Variance is nothing but the square of standard deviation. Okay, or the square root of variance is standard deviation. So if I square the variance, if I square the standard deviation, that is variance. Now there is a fixed formula is there for standard deviation. Again, whenever I say formula, you need to remember both the formulas. One formula for individual series, or the one without group, or we can also call it as individual series formula. Another formula is that the formula for continuous series. Okay, the formula for individual series is root of sigma x minus x bar the whole square divided by n. Here x bar always indicate that it is mean, x indicate that it is the individual item. So this is the formula. There is no shortcut for the formula. You just have to remember it. I mean, it is a square root of sigma x minus x bar the whole square divided by small n. N indicate that the number of items, x bar indicate that the mean, and x indicate that the individual items in the series. Variance is what? You take out that square root, that becomes the variance. Okay. Now another one is, this is the formula for standard deviation. This is the formula for variance. What is the formula for coefficient of variance? If they are asking, that is standard deviation divided by x bar into 100, right? So these are all three different formulas that you need to remember in this particular chapter, especially the formula of standard deviation and variation. Now they have given one simple problem on this discrete series, on individual series. Calculate the standard deviation and its coefficient from the following data. And they have given, so as soon as they give this data, you have to, what is the formula? It is x minus x bar the whole square. So that means I just need to find out what is the mean for it. How do I calculate the mean? Which I have already discussed it in the last class. That is 10 plus 12 plus 16. Add all those things divided by number of items, which is 10. So the x bar comes 15. So x minus x bar, you need to put it. X is what here? It is 10. X bar is 15. So 10 minus 15 is minus 5. 12 minus 15 is minus 3. 16 minus 15 is plus 1. So like this, you have to write it down all the series considering the difference. Okay, and in again in the book there is a small printing mistake. The small printing mistake, and the printing mistake is they have not mentioned it as x bar, they have mentioned it as x. Okay, so you just put x bar on top of it. Okay, on the title part of numbers xi minus x dimension, that is xi minus x bar, xi minus x bar the whole square. Just put one bar so that you can avoid some confusion. So again you have to square that x minus x bar the whole square. That means minus 5, square it off, minus minus becomes plus. So naturally you all will be getting the positive values. So finally you have to sum it out, and you have to replace these values in the respective formulas of standard deviation. The formula of standard deviation is sigma x minus x bar the whole square, that is 446, divided by n is 10 in this case, and the value of standard deviation is 6.7. And the coefficient of standard deviation, as I have told you, it is the ratio of standard deviation divided by x bar. So clear with this, guys? Can we go on to the next one? Can you just give some kind of feedback in the chat? Is it okay? You are able to understand? Now this is not going to be a lecture, guys. You just remember that, like say one friend is quickly going through the subjects to another friend. That's it. You don't think something beyond this. Are you able to understand? Others? Ashika said yes. Are you able to? And you cannot understand if you don't have book or soft copy in front of you. That also I'm pretty sure about it. You just please sign out of this chat and leave. If you're hearing this as a lecture, because there's no attendance for you, you requested, that is why I'm taking. That's it. If you're hearing, if you're hearing, okay, 1 minute, guys. One minute. So now whatever that we have discussed is 1 minute. Whatever that we have discussed is only for the, okay, 1 minute. Just give me 1 minute. Getting some message. Okay, right. So now, as I have told you, whenever I talk about formula in stats, this formula is applicable only for individual series. But that means I can also use the word discrete series. Both doesn't have much difference. Another formula is there's a formula for continuous series. Now the continuous series formula is that they have given it in solution number yeah number 2 that they have mentioned. No, that is the formula for continuous series. That means standard deviation is equal to square root of sigma fx square divided by n. So please correct it. They have not mentioned it properly. Again, there is a printing mistake. Okay, minus, they have mentioned it as x square. It is not x square, it is x bar the whole square. Okay, that's it. Okay, there is a lot of printing mistake in page number 62. uh, there you can see two two questions. Go for the second question. You consider the formula of the one for the first question. Okay, please correct the formula that they have mentioned. It is square root of sigma fx square divided by n minus x bar. Okay, x bar the whole square. Okay, if you look at this, if you look at this, consider this, keep this formula as the reference. We'll discuss only the second problem because there is again some printing mistake in the first problem. Now they have given this question in terms of continuous. I had a question for am. Please, what is the question, Varisha? Go ahead. Yeah. So if you look at this particular formula, what we have to do is that, as usual, whenever they are giving the marks in terms of range, you have to find out the mid value. Put the mid value. Mid value of 0 to 2 is 1, 2 to 4 is 3, 4 to 6 is 5, 6 to 8 is 7, 8 to 10 is 9, and that becomes x. And after that, it is fx. Okay, fx, and it is fx square. That's it. Fx square. That means fx is mod. Just multiply f and x, and after that you square that x. That is a mid value. Square means what? 1 square is 1 into f, which is again 10, so it becomes 10. 3 square is 9. 9 into 20 is 180. 5 square is 25. 25 into 35, it is 875. So like this, you need to find the arithmetic mean. No, Varisha, just if this is, I don't think so. This is something related with the stats, what we're discussing right now. Keep it with you itself. We'll discuss some other time because I don't have so much time right now. Okay, so just listen only. If there is any doubt on the topic which I'm discussing, that you please raise a voice. No need to raise, just put it in chat. I will have a look at it. So now this is the method you need to solve this. And x bar, it is it is it is the fx divided by n because it has a frequency involved in it. So x bar you find out. So I have told you what is the formula: sigma fx square divided by n, which is 2940. N is 100, which I have already mentioned, minus, it is not xy but it is x bar. Okay, if you want to consider it as xy, that means it is actually not xy, it is fx. It is actually fx. There are a lot of printing mistakes in this book. I'll tell you what is the formula, if at all. Can I add some? I'm just thinking, what is the correct formula? How do I write it? Okay, it is not xy, it is x bar. Okay, it is x bar, or you can also mention it as sigma fx. Or I can, if I'm able to share the screen, I can just show that online itself what is the correct formula, because there is a printing mistake in the book. I'm sure you are able to understand based on the solution what they are actually trying to convey. So that's it, guys. You just have to solve it and you'll be getting the answer. And if they're asking for variation, you just have to square it. That's it. And if they're asking for coefficient of standard deviation, make it very simple. Standard deviation divided by x bar. Are we clear, guys? We are almost done with this chapter. Are you clear with this? So the crux is the formula. You should know the formula of standard deviation for individual series, and also have, and also, oh, yeah, good one. But it will be the mirror image. I'll show you. One minute, guys. I'm writing down the formula so that you can have a look at it. So that I'll show that to you. I don't know whether you can see this. No, you can't. You can't see this. I'll do one thing. One minute, guys. Guys, I'll take a photo of this and put it in the. Okay, this is the correction which I wanted to. No, I have already shared it in the. That's okay, man. Let them know that taking class. That is okay. It's only online, no, so long as I'm not clashing. Okay. Okay. So this is what it should have been, but so this correction you make it in your book also, so that you don't do any blunders. Okay. So guys, can we go on to the next one? There's nothing to talk much. The crux of this chapter is very simple. There are two formulas for standard deviation. Don't ask me what is the formula for variance. Variance is nothing but the square root of, which is the square of standard deviation. Two formulas for standard deviation. One formula is for individual, that is the one without this range and other things, and another that is the one without the frequency or the range, and the other one is with frequency and the range. And the one formula is that square root of sigma x minus x bar the whole square divided by n, which is pretty easy to remember it. Another formula is root of sigma fx square divided by n minus sigma fx divided by n the whole square. So these are the two different formulas. I think the top one also you can ignore it. The one which I have, I think this one, again this one you can ignore it. The one which I have highlighted, the first formula, no, the page number 62. Only you can remember this formula. Okay, this is more than sufficient. That means either you remember it as x bar, or you can remember it as sigma fx divided by n the whole square. Any one, both has the same meaning, doesn't make much difference. So basically there are two formulas for standard deviation, and when it comes to the variance, it is quite simple. Take a square of the standard deviation, that is variance, and the formula for coefficient of standard deviation is that whatever value that you're getting as a standard deviation divided by x bar. That's it. So guys, can we go on to the next chapter? Can we go on to the next chapter? We can't spend much time. Yeah, okay, fine. So now I have given one a particular topic as an assignment for you, which you can read it on your own. That is on mean deviation. I have not covered it, considering that they have not asked any question in the past, and taken the fact that it is not very much important also, you can read on your own. Okay, that is assignment that I have given. So like this, in every chapter, one or two topics which I feel it is not important, I might give it to you so that you can have it for your reference. Okay, right. So now after this, we are going to wind up this class in another maybe 20 minutes. It's going to be a pure theoretical session. There's nothing to do with formulas or problems, nothing doing. Okay, so this chapter is all about, and after this chapter it's going to be a complete, a very big problems are going to come, especially related with the t test, z test, f test, all those kinds of tests. So now we're going to cover all the basics of the uh, theoretical part. Now this is all about the theory of sample and sampling. Now what is meant by population? So there's a concept called population and sample. So what is meant by population is that it is that particular kind of, see, population is the universe. We call it as universe. Now whenever I wanted uh, to to check something, whenever I wanted to uh, find out to find out the characteristics of the population, find out what is the mean of the population, it is sometimes it becomes impossible for me to find out the mean of the population. The reason being, because there might be n number of people in the population. If my population is only AU class, the number of students is only 39, then I don't have any problem. If my population is a country like India, which has 130 crore people, then I am actually dependent on the sample. That means I cannot inspect each and every person of the population to come to a conclusion that yes, so and so. See, for example, if I wanted to know that what is Indians' opinion about Donald Trump, that means is he a good guy, bad guy, or a stupid guy, whatever it is. Now, what do I do? That is it possible for me to check each and every person in the country, all 130 crore people? The answer is a big no. It is almost impossible. But I wanted to know, is Donald Trump a good guy or a bad guy? This is the opinion which I wanted to know from the people. But it is almost impossible for me to find it out, because I need to check it out with 130 crore people. So now what do? I do consider something called sample. So I take some 10% of the population. I take some 1% of the population. There is a calculation for it. How do I have to calculate the sample size based on the population? So I take some 100 people from Tamil Nadu, 100 people from Kerala, 100 people from Andhra Pradesh, Delhi, Kolkata, Gujarat, and I come to a conclusion that what is Indians' opinion about Donald Trump, right? So now that is what we call it as sample. So when you take a particular section of the population which represents the population, and you come to know about whether this is the characteristic of the population. This is what we call it as sample. Okay, if at all in this live chat, if I ask anyone, okay, I mean, let's say I may ask randomly, let's say I will ask somebody like Rohit, are you able to understand the class? If he says yes, then I come to a logical conclusion that yeah, if he is able to understand, other students whoever have logged in, they can also understand. So now this is what we call it as sample. Now what is meant by sampling? What is meant by sampling? The way how I draw, the way how I draw the sample from the population is what we call it as sampling. And why did I say Rohit means? I didn't have any particular bias. I just picked him up randomly because I saw his name, right? That means the way how I draw from the population. Say for example, if I'm taking class and I let's say that somebody is sitting in the first bench, I may ask questions somebody who sits in the first bench. If at all I wanted to check it out whether everyone has understood, then I may ask someone from the last bench. And then I come to a conclusion that okay, if last bench students are able to understand, the other bench students can also understand. Now this is what we call it as sampling. That is the way how I draw. Am I going to draw based on my judgment, or am I going to draw based on some simple random sampling method, or am I going to draw based on my own convenience? This is what we call it as sampling. So that means the way how I draw the sample from the population. On what basis? On what logic? This is what we call it as sampling. Now, the other one is that parameter and statistics. These are the two words that you also have to remember. Whenever you talk about the metrics of the population, or I use the word metrics like what type of metrics that I will be using? I will be using metrics like mean is one metric, standard deviation is another metric, variance is another metric. So now this is what we call it as parameter. That means whenever I talk about the metrics of the population, I use the term parameter. Whenever I use the metrics of the sample standard deviation, sample variance, okay, sample mean, this is what we call it as statistics. So please guys, I have told you two terms, don't get confused. I'm not talking about statistics subject. When I talk about the metrics of the sample, I use the word statistics. Metrics like sample size, metrics like sample mean, metrics like uh, sample standard deviation. If I use the metrics, if I use the metrics of the population, I use the word parameter. Metrics like population mean, metrics like uh, population standard deviation. So all those things that has been mentioned. So whenever I say, you just, if you're able to understand, it's okay. If you're not able to understand, you can cross check in the book itself, which is there in page number 65. Right. So now I have told you about the logical reason of why do we need a sample, and let's say that why do we need sample, guys? Because so that we can save time and money. See, if at all if somebody is preparing the biryani, okay, do you want to taste the full anda of the biryani to check out whether the biryani is taste or not, or will you take only one scoop and check? Anyone is from Hyderabadi biryani is there? You take only one spoon, no, and check, yes, the biryani is very tasty. That is what we call it as sample. If you are preparing rice, do you want to check each and every granule whether it has been cooked properly or not, or will you take any one granule and you come to a logical conclusion that yes, this is what we call it as sample. And the way how I draw is what we call it as sampling, right? So now when it comes to this, now you can read the advantage, you can read the advantage, disadvantage, and of this of a sample, okay, which is quite simple, which is nothing to explain much. Okay, the main advantage of sample, I would say, it is time and money. I can save a lot of time and money because I don't have it. Okay, that's the main advantage. Now the second aspect of sampling is that there are two different type of sampling technique. What is meant by sampling? The way how I draw the sample, the way how I draw. Say for example, if I if I write everyone's name in a chit, let's say that I'm going to ask questions from any one student to understand whether you have understood or not. Now, every time if I'm asking the same person, you will come to a conclusion that okay, once the class gets over, a sir will ask questions only from say Ashika or say from Varisha. So that means Rohit means will not be active. Shubham Patidar will not be active. Balendu might not be active. So what do I do instead? I write everyone's name in a sheet, shuffle it, and I take. That is what we call it as sampling technique. So like this, there are two different kind of sampling technique. One is that probability sampling, and another one is that non-probability sampling. What is meant by probability sampling? Probability sampling is when I allow each and every member of the population to be a part of the sample is what we call it as probability sampling. Let's say that we are running on chit funds and you all are giving some thousand rupees every month, and we are a group of we are a group of 13 students. Now, whoever names comes first, he will be getting how much? 13,000 rupees or 12,000 rupees or 11,000 rupees. How much you will get? Chit funds by Amir. Okay, every month you will give 1,000 rupee. Um, if a lucky draw person, they will be getting 12,000 rupees. Okay, not 13,000 rupees. 1,000 rupees for me because I am running chit fund. No. So now this is what we call it as probability sampling. That means I'm allowing each and everyone to be a part of the sample. So non-probability sampling is that non-probability sampling is that the one which is based on convenience. Okay, we'll get deep into this. When it comes to the probability sampling, the first classification comes as simple random sampling or random sampling. What is this simple random sampling? Is that let's say that the same example that I have told. Let's say that I'm mm, I'm taking class for a group of 100 students. Okay, and I wanted to know the feedback of the class or the feedback of the session from only 5 students. Now, on what basis I will select the five? Am I going to select only the first benchers, or am I going to select only the last benchers, or am I going to select only the middle benchers? Or am I going to select the top 5 students as per the attendance list? Or am I going to select only the toppers or only the backbenchers? So these are all the questions which I have. What do I do? I'm allowing each and every person to be a part of the sample. So what do? I write each and every student in a share in a chits. I I fold it, I shuffle it, and I take only 5 out of 100. So when I does it, I am allowing each and every one person to be a part of the sample. This is what we call it as probability sampling. Okay, simple. That is simple under probability simple random sampling. So under this simple random sampling, I have several methods. Lottery method that I have told you just now. When it comes to every year, from India, some set of people they go to Hajj. What type of sampling technique they use? Because government gives some subsidy to some limited set of people. So if 1 lakh people are applying, let's say that the government might give subsidy for 50,000 people, and they will ignore the another 50,000 people. Now, on what basis they will select 50,000 people? They will select based on the lottery method. So lottery method is the most effective method that I have told you just now. And you can also use a simple random number. You can use it through Excel. Okay, you can also select from sequential list, grid system. There are different type of technique that I can use. You don't need to explain all those technique. I mean, two techniques is very popular. One is that random number table you can use, and another one is that lottery method you can use. And you can have the list of advantage. It is scientific, it is not biased, it doesn't have any special love or any special hate towards someone. These are all the advantage and disadvantages of random sampling. The second type of sampling is stratified. That is okay. The second type of sampling, I'll talk about the stratified sampling. Third, I'll talk about systematic sampling as a second, which is in the next page. What is this systematic sampling? The same case. Okay, I have taken class for a group of 100 students. Okay, and I wanted to check whether students have understood, and I wanted to check from whom, from 10 students. Okay, If I write all 100 students' name and shuffle it and take from that shuffle, that is what we call it as simple random sampling. Instead, what do? I divide the population by the sample. Okay. When I divide the population by sample, what is the population here? 100 students. What is my expected sample that I'm planning to take is 10. 100 divided by 10, what is the value that I'm getting? 10 is the value that I'm getting. So now this 10 is the interval. After this, I will ask a kid like Rohit means, okay, tell me some lucky number from 1 to 10, and you say, sir, abracadabra, take 6, sir. Okay, so what do? I pick up the sixth person, and my interval says 10. How did this 10? Population divided by sample. This 10. So Rohit means said, sir, my lucky number is 6 from 1 to 10. So I will take sixth person. I will ask the 16th person. I will ask the 26th person. I will ask the 36th, 46th, 56th. Like this, I will go on till the 96th person so that I will get all 10 people without any bias. Are you able to understand this systematic sampling? What I'm trying to convey. First, you have to find out the interval. On what interval that I'm going to take. How do I find out the interval? How do I find out the interval? Population divided by sample. Population is 100, sample is 10, which is 10 is the interval. Keep this one aside. Other side, take a kid, ask the kid, tell me some random number from 1 to 10. Keep in the sense, take some random number. Let's say 5 or 2. If it is 2, then 2, 12, 22, like this. Go on. So this is what we call it as systematic sampling, guys. Are you clear with the systematic sampling? Can you go on to the next one? Okay, I presume that you have understood. I'm going to the next one. The second one is stratified random sampling. What does this stratified random sampling means? Let's say that there are some three classes and I'm taking the same subject for all the three classes. I'm taking marketing management subject for PGDM students. I'm taking marketing management subjects for BCU students. I'm taking the same marketing management subjects for AU students. Now, I wanted to know whether the subjects what I'm teaching the students have understood or not. But again the problem is I can't come to a conclusion that the intelligent level of students, the acceptability level of students, or the atmosphere of AU class is not same as the atmosphere of BCU and PGDM class. So now what do? I'm planning to take some set of students proportionately from PGDM, proportionately from BCU, proportionately from AU based on random sampling. Let's say that I have taken, there are 50 students of BCU, 40 students of 40 students of PGDM, and there are some 10 students in AU. I will take one student from AU because that's the proportion. 4 students from PGDM and 5 students from BCU. And how do I select? Will I select the person who is sitting in the first bench? No. What will I do? I will write each and every person's name in the chip, shuffle it, then I take. This process is what we call it as stratified random sampling. Let me explain the theoretical part of it. When I use the word stratified, this strata indicate that it is group. So now, what is the step that is involved? Step one, I will divide the population into different strata. Strata indicate that it is group. Okay, first one, number one. Number two, in this case, what is the different strata? Strata is AU class, BCU class, PGDM class. Step one over. Second thing is that I will select the students proportionately. Step 2, from different classes. That is, proportionately means what? Depending upon how many students are there in a particular class, that means depending upon the, I will choose the sample from different status proportionately. That means 4 from PGDM, 5 from BCU, and 1 from AU. Third one is that on what basis I will select? Will I select only the first bench students, or will I select those students who are pet to me, or will I select only those students who I do like or who I don't like? No, I will select the students based on simple random sampling. So these three steps I will be doing it as a part of stratified random sampling. Divide the population into different stratas. From the respective stratas, choose the students proportionately in a random manner. Okay, in a random manner. Okay, the last one is the, under which comes under the sampling, is the cluster sampling. What is this cluster sampling? The same one. Let's say that AICT is coming to our class for inspection, and they wanted to check whether students are happy with the classes, they are happy with ideas, is the classes are happening or not, what are all the things. Now, AICT is having three choices. Do we have to go to PGDM students? Do we have to go to BCU students? Or do we have to go to AU students? Now, what they do, okay, they will shuffle. I mean, they write all the classes name, and they are getting only BCU. Let's say that they are getting BCU. So they go to BCU class, and they take a survey from each and every student within BCU to know what is the feedback of the students towards the college administration and the academics. This is what we call it as cluster sampling. How, how do I explain the theoretical part of it? I divide the population into different clusters. Different clusters, in this case, it is BCU, PGDM, and and BCU, PGDM, and AU. From these three, I will select randomly. Randomly, let's say that in this case it is coming BCU. And from that randomly selected group, I will check each and every member of the class, member of the cluster. This is what we call it as cluster sampling. Now, you should be able to find out the difference between stratified random sampling and cluster sampling. The step one is same both for stratified random sampling and cluster sampling. What is step one? Divide the population into different groups. In step two, in stratified random sampling, I will choose the members of the strata proportionately in simple random manner. In cluster sampling, I will choose the cluster and I will check each and every person in the cluster. Clear, guys? Do you understand the difference between stratified random sampling and cluster sampling? Okay, fine. So, guys, I prefer to wind up the class uh, now. Okay, we will continue. I think the theoretical portion which is left is non-probability sampling, which is not very difficult. We will discuss it. Okay, or maybe I can talk about non-probability sampling. See, non-probability sampling. Let's say that in this case, I think it is not very difficult. Okay, non-probability sampling is what, when you are selecting the sample based on your own. Okay, I will tell the date. Okay, let me not drag it further. We will continue in the next class. Um, so maybe I'll let you know about it. Okay, I will let you know about it because I need to schedule, and moreover I need to prepare also because this is a new subject for me. That is, I'm not committing any date. So guys, thanks for your time. We will wind up the session now. Okay, bye bye. And time, even it becomes difficult for other teachers. Yeah, I will. Okay, I will put it in the group. This time is fixed. There's no change in this time. Friday 11 is fixed. Other time, one or two more classes in a week that I will let you know about it. Okay, thank you guys. Thank you. Bye bye.